Induction current. Our next topic to be understand is induction current. Now, what is induction current? Let us find. We have taken a circular coil and we have taken a 9-volt battery. Now, let us connect the battery to the wire to make it a complete circuit. Now our circuit is complete. Then the one end of the terminal is connected to one end of the wire. Then one end of the battery terminal is connected to the another end of the wire. Now our circuit is complete. Now on the other hand, we have taken a circular coil and connected to an LED bulb. Now let us find out how the LED bulb is glow when we bring the LED bulb in the field of the circular coil. Now you can see there is glow inside the LED bulb. When the LED bulb is moved away from the field of the coil, the LED bulb puts off. Now again when we bring back into the field of the coil, the current is passed to the LED through the coil. Now when it is moved away, it puts off. And when it is brought near, it puts on. Now what is behind it? Now the circular coil is connected to the battery. The moment the circuit is completed, the current is passing through the coil. Wherever current is passing, electric field is associated around it. And according to the Oersted experiment, wherever electric field is associated, magnetic field is also associated around it. The magnetic field around the circular coil induces the electric field inside this coil. This is the induction from this coil to this coil. I repeat, the magnetic field produced around this circuit creates the electric field inside this coil, and that causes the LED to glow. This is our induction current. The moment the coil is moved away from the region, it puts off. The moment the coil is brought near the region of the magnetic field, the LED glows. This is induction current. Now, Faraday's law of electromagnetic induction states that whenever there is a continuous change of magnetic flux linked with a closed coil, a current is generated in a coil. I repeat, Faraday's law of electromagnetic induction states that whenever there is a continuous change of magnetic flux linked with a closed coil, a current is generated in a coil. Now, to understand that, first we need to understand what is magnetic flux. Now, let us take a bar magnet. It will have a north pole and the south pole. Around the magnet, there will be magnetic field lines from north pole to the south pole. From the north pole to the south pole. These number of lines, these number of lines indicates the magnetic flux. More the number of lines, more the magnetic flux. Now, what Faraday, what did he did in an experiment? He took a closed coil and he connected the coil to a galvanometer. Now, what is a galvanometer? Galvanometer is a device which measures the current in very minute quantities. I repeat, what is a galvanometer? Galvanometer is a device which measures the current in minute quantities. And then what he did, he took a bar magnet, he took a magnet and he brought it near to the coil. He took a magnet and brought it near to the coil. Now, as there is a change in the magnetic flux around the coil, the current is produced inside the coil. This current causes the deflection inside the galvanometer, indicating the presence of current that is generated inside the closed coil. I repeat, what is Faraday's law of electromagnetic induction? Whenever there is a continuous change of magnetic flux, I already said what is magnetic flux. The number of magnetic field lines present around the magnet, that is a magnetic flux, linked with a closed coil. A current is generated in a coil. Faraday connected the circular coil to the galvanometer. He brought the magnet close to the coil, and whenever there is a change in the magnetic flux around the coil, the change in the magnetic flux, the continuous change in the magnetic flux causes the current to be generated in the coil. That is proved by the deflection inside the galvanometer, indicating of the current.